Now, culture of microorganisms, really, really important. For bacteria, the way that you're going to know it's one thing over something else is they're going to tell you what it did on a certain type of media, or they're going to tell you it grew on one thing and not on something else, okay? So for bacteria, this is really important. And think about this. When we move on to viruses, we don't have this. We cultured the virus on this, and this. We have basically symptoms for viruses and some pathology, all right? So this is really crucial for the bacteria that we're going to cover. So I'm going to give you an introduction now to some of the different types of culture media. And then when we start talking specifically about the bacteria, I'll mention them again. And again, they are really important. Now, for the obligate intracellulars, you're probably not going to have to worry about how those are cultured, okay? They're not going to tell you something grew in an egg, all right? So that's a little bit less likely to show up. But the facultative intracellular or extracellular, that's where you're really going to get hammered, and you really have to know your stuff. The types of media that these guys grow on is really important, all right? And I'll give you an example in a minute, but I'm going to give you first the example of McConkey agar, okay? Because it fits in these two properties we're getting ready to talk about. McConkey agar, which grows the enteric organisms, is both a selective and a differential media, all right? So what do I mean by selective? We grow the enterics on McConkey agar. We know that they grow on that agar, but it selects for those gram-negative organisms. Gram-positives don't grow on McConkey, so it selects for the gram-negatives. How critical is that? Simple. If they tell you that they did a culture, from a patient specimen and it grew on McConkeys, and you look at the differential or the distractor list down below and you see gram-positives, you can cross them off the list. So how important is it? I'd say very important. Anything that gets you to narrow down the list of possible correct answers is really going to be important for you. Now, if you look at the differential, what does that mean? That means that the particular type of medium helps you differentiate the bacteria based on a certain property. And McConkey agar does that because it determines those organisms that ferment lactose. How important is that? Well, it's important enough to help you differentiate E. coli from Salmonella, from Shigella, and a lot of those other enteric organisms. So selective, we're selecting for the growth of a certain type of bacteria. Differential, we're helping to differentiate between a property that the organism has, with McConkey agar really being probably one of the most important. Okay? What I'm showing here are some of the different types of medium. McConkey agar is shown here such that if an organism ferments lactose, there is a pH indicator in the medium, and it's going to turn those colonies pink. So a lactose fermenter on McConkey is going to be pink. Down at the bottom, this is EMB agar, eosin methylene blue. And EMB agar a lot of the time is used to culture coliform bacteria, bacteria that are normally found in the gut. Used quite often to determine if there's a water supply that's contaminated by feces, because E. coli will turn a metallic green on EMB, and it's very easy to pick out if you're screening large numbers of samples. All right, go up to the top, BCYE. This is buffered charcoal yeast extract. And BCYE grows organisms like Legionella, for example. So if you have a case where you have kind of an atypical pneumonia, and they tell you that the organism didn't grow on McConkeys, for example, but it grew on buffered charcoal yeast, you know that it's Legionella. So it definitely helps you determining the causative agent, all right? Chocolate agar, you're definitely going to see chocolate agar. That's really important for culture of the Neisseria, so Neisseria meningitidis and gonorrhea, as well as Haemophilus. So we're definitely going to come back to chocolate agar when we talk about those organisms. Chocolate agar is essentially blood agar that's been gently heated to release all the components in the blood, so that the organisms that do not have the capacity to lyse the blood can access the components in the blood. Okay? And while we're on the topic of blood agar, well, it's not shown here. We're going to show it when we talk a little bit more about staph and strep. Blood agar is another one you definitely want to know. And when we're talking blood agar, we're talking alpha, beta, gamma hemolysis. And again, we'll talk about that when we hit staph and strep. TCBS is a sucrose-based medium that is used to culture the vibrios, because vibrio ferments sucrose and will actually turn that culture medium orange. Okay? So those are some different examples. It's not a comprehensive list, but what we will do is when we talk about the organism specifically, we'll mention the type of media. And again, I'll try to, pound in there how important the different types of media are. Okay, growth requirements, again, for mycoplasma, and these are just kind of random, and again, probably better suited when we start talking about the organisms themselves. But mycoplasma requires cholesterol in the medium. Remember, as far as the Ellas, Francisella, Brucella, Legionella, Pasteurella, those require cysteine. And probably one that you're all familiar with, Haemophilus and the 5 and 10. Haemophilus requiring X and V factors in order to grow. And X is actually heme, and the V factor is NAD, which are both found in blood. Okay? And so if you look at the example we have down here, you can see that for Haemophilus, not grown on chocolate agar, the only place that the organisms can grow are between the X and V factors, because it's requiring both. So where X and V both kind of transfuse into the media, Haemophilus can access them and actually grow. So those are just some random facts for you to know, and again, we'll talk about them a little bit more specifically when we get to the organisms themselves.